All right, there we go. So finding missing angles of right triangles today, following from yesterday's, finding missing sides of right triangles. Here we go. So this is kind of day 3 of 9.4 and 5. Finding missing angles of right triangles. Okay, so this is going to go very similarly to the way things went um, with finding missing sides. We're still going to be using sine, cosine, and tangent, needing to remember so, ka, toa. So let's go ahead and write that at the top of our paper real quick. Refreshing our memories here. So everybody real quick, put down what sine is, what cosine is, and what tangent is using so, ka, toa. What do they stand for? Take a moment. Try to get those from memory or from that little hint there. And then we'll move on. All right, so hopefully you chose opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. So that's something we kind of want to have in the back of our mind or at the top of our paper as we go through finding missing angles of right triangles here. Now, a lot of people think that finding missing angles is simpler than finding missing sides, and they'd be correct, or at least I think they're correct. So what we're going to do today, I think, is a little bit simpler. So again, this is going to be something just like yesterday that involved kind of learning with examples here. Once we see a couple of examples, I think that we will catch on to this. So it's also going to be something that if you really like doing things in steps, this does lend itself well to that. So first example, got our right triangle here, A, B, C. This side length is 13, this side length is 4. You can use just 2 side lengths to find a missing angle. That's all you need is 2 sides. So, for example 1, we are going to first find the measure of angle A. So, step 1, identify which 2 sides you have. With respect to the angle that you're looking for. So looking at angle A, the 2 sides that we have are these two, 13 and 4. So with respect to angle A, what are they? Are they opposite, adjacent, hypotenuse? What do we think? Which 2 do we have? All right, so what do we think 13 is? Everybody asleep today? Are we all just still writing? Hypotenuse. Thank you. There we go. 13 is the hypotenuse. It's across from the right angle. What about 4? Adjacent. Thanks, Jade, saving us there. All right. So we have adjacent and hypotenuse that we're working with here. So that's going to help us when it comes to choosing our trig function that we want to use to help us make an equation. So step 2, choose sine, cosine, or tangent, and it's based off of the 2 sides that we had here. So since we have adjacent and hypotenuse, we want to use the one that involves adjacent and hypotenuse, which is cosine. So in this case, we're going to use cosine. Step 3, set up an equation. Okay, so the way this equation is going to look, we're going to have cosine of angle A equals, and then, so this is going to look a lot like the stuff that we did a couple days ago when we were just figuring out based on the 3 sides, what is sine, what is cosine, what is tangent for an angle. So in this case, cosine of A is adjacent over hypotenuse, so it would be 4 over 13. So this is an equation that'll work for us. Cosine of A is 4 over 13. So little did you know before, 2 days ago when we were writing things down like this, that this is actually an equation that we can solve. But it's not an equation that we can solve by like the traditional method that we would, like multiply by 13 on both sides or something like that. That's not going to work here. And like we did with the sides yesterday, we just typed like cosine of 45 or cosine of 23 into the calculator. That's also not going to work here because I can't type cosine of A into the calculator and get anything meaningful out of it. But in math, particularly in algebra, algebraically, anything you can do, you can also undo. If you can square something, you can square root something. If you can multiply, you can divide to undo it. Everything has an inverse here. And so does cosine. Cosine has an inverse. Sine and tangent both have inverses. And it's a button on your calculator, actually. So on most scientific calculators, it's a secondary function. So if you've got a calculator like this, you see your sine, cosine, tangent button. It'll have a sine with a little -1, cosine -1, and tangent -1. That stands for sine, cosine, and tangent inverse. So if I hit second and then cosine, it puts cosine inverse onto my calculator. So what we can do on both sides of the equation here is we can put cosine inverse. Because if I do to one side, I have to do it to the other. And what it does is it cancels out the cosine. So A is equal to cosine inverse of 4/13. And that is something I can type into my calculator. Cosine inverse of 4 divided by 13. Enter. And that's equal to 72.0797, bunch of stuff. So we'll round this to 72.1 degrees, since that's what IXL tends to want, is rounding to the nearest tenth. And that is angle A. If you were doing this on Desmos, which you can do, if you open up a window of Desmos, as usual, the first thing that you want to do when you go to Desmos is click on the wrench and make sure that you highlight degrees. This should be in degrees. So click on degrees if it's not already highlighted, and then you can come over here and grab the keyboard, and And if you go to functions, you'll notice that sine inverse, cosine inverse, and tangent inverse are in this middle column under trig, right next to regular sine, cosine, and tangent. So you click on cosine inverse, and then 4 divided by 13, and it gives you the same answer here, 72.079786. So you can just round that to 72.1 degrees. All right. So that is how we use inverse trigonometric functions to find missing angles. Okay. And then once we have one missing angle here, we know that this is now 72.1 degrees. And we know that this is a right angle, so this one is 90 degrees. Finding the measure of angle B becomes really easy. What can I do to find the measure of angle B? If I know two of my angles. Okay, sure. You could do it this way as well. You could go from angle B's perspective and now go 4 is opposite and 13 is hypotenuse and do inverse sine of 4 over 13. That would work. That is definitely one way you could do it. There is an easier way. Does anyone see it?
Subtract by 180.
There we go. Yes. Subtract from 180 because we know it's a triangle and all three angles add to 180. We can go 180 minus 72.1 minus 90. Or you could really go 90 minus 72.1. You get the same answer either way. But we get 17.9 degrees for the measure of angle B. But yes, you could also do Caleb's way, especially if you want extra practice on finding missing angles on right triangles here. You could also go sine of B equals 4 over 13, and then take the inverse sine of both sides to get that B is sine inverse of 4/13, which rounds to 17.9 degrees. Either way, you'll get the same thing. It's just a different way of getting there. This actually might even be quicker to type into the calculator. It's a little bit more mental work than this one is, but yeah, whichever way you want to do it is totally fine. I like that we saw both. Awesome. Any questions so far? Any numbers we're not sure where they came from? Steps we're not sure how they happened or what's going on? Okay. Then let's try another one real quick, and then I'll have you guys do one on your own, and then we will move on. We'll call this one angle D and E and F. And this time we'll be given that this is 10 and this is 18. And this time we want to find the measure of angle D first. Okay. Finding the measure of angle D. First step. What two sides do we have with respect to angle D? Opposite and adjacent. Awesome. Yeah. We're missing the hypotenuse. We have opposite. We have adjacent. So what should I use? Sine, cosine, or tangent? I'm working with opposite and adjacent. Yeah, tangent. So if I'm going to use tangent, go ahead and set up an equation real quick that will help us find the measure of angle D using tangent. When you think you've got your equation, put got it in the chat. You started off with tangent of angle D. You're on the right track. And then what's it going to be equal to? Is it 10 over 18 or 18 over 10? What do we think? Well, for dealing with opposite over adjacent, yeah, 10 over 18. Awesome, Marissa. Tangent of angle D is 10 over 18 since that's opposite over adjacent. So then, last step, we do tangent inverse on both sides. So we get that angle D is tangent inverse of 10 over 18. So tangent inverse of 10 over 18, you want to grab your calculator or your Desmos, open a window for that. And we would type second tangent 10 over 18, enter. And we get that angle D is 29.1 degrees if you round to the nearest tenth. Okay. So then on your own, find the measure of angle F using whichever method you like. Go ahead and find the measure of angle F. When you've got it, put got it in the chat. All right, Adon's got it. Jade's got it. Awesome. All right, 10 seconds, and then we're going to talk. All right, nice job, everybody. So you could either go 180 minus 90 minus 29.1 and get 60.9. Or you could have done inverse tangent of 18 over 10. That would also work. Either way you want to do it, it's totally fine. Okay. So next, I'm going to give you guys one to try on your very own. And then we'll probably move on to the homework assignment from there. Let's see, we'll go with 47 and 26. Find measure of angle P. All right, so go ahead, find measure of angle P on this triangle. And then when you think you've got it, put got it in the chat. All right, Jade's already got it. If you chose to use sine, you're on the right track. All right, everybody's getting it here. Sine of p equals 26 over 47. If that's the equation you set up, you're doing good. Then we do sine inverse. So in your calculator, second sine, 26 over 47, which gives us about 33.6 degrees. And then from there, go ahead and find the measure of angle S real quick. Some of you looks like you're already ahead of me there. We should get 56.4 for the measure of angle S. Okay, so on a scale of 1 to 5, 1 being this is super confusing, 5 being this is super easy, what are we feeling for these? All right, cool. Looks like mostly 3s, 4s, 5s. Okay, so this is going to be another day where I'm going to post the assignment, and then if you would like to stick around and do some more examples with me or do some specific ones out of your IXL section, you can, and we'll have the opportunity for extra help there. So today's assignment is another IXL section. It's only one again. I cut one of them because I decided it was not all that helpful. So this one, trigonometric ratios, find an angle measure. The only thing that's a little bit different about this IXL section is sometimes they'll put things like 3√3 as a side length, which isn't all that different or terrible. There's just a couple things you have to remember to do notation wise. And when you type into the calculator, a few things we have to be careful of. So for example, in this first one, if I'm finding the measure of angle V, this looks a lot like the one that we just did. You have 3√3 and you have 6. It's the opposite in the hypotenuse, so we're going to use sine. And the equation, or what I'll end up typing into the calculator is sine inverse of 3√3 over 6. So when I type this into the calculator, we grab our sine inverse here, 3√3, which you can get down here from the root, or you can type SQRT. That's the keyboard kind of shortcut for that. And then you have to make sure you kind of tab over a little bit and then to get out of the square root, and then have it be over 6. And then it tells you what the angle measure is. In this case, it's 60. If the 3√3 were on the bottom, you would have something similar going on. Let's see, if you had something with a root in it. Let's go 2 over 3√3. You would want to make sure that the whole entire 3√3 is in the denominator. So you want to be careful there. If you're doing it on a scientific calculator, sometimes that can get tricky with trying to get things into the numerator or the denominator and whatnot with fractions. So if it's in the numerator, it'll be fine. But if it's in the denominator, like 2 over 3√3, you'll want to put a parentheses, 3 square root 3. Close the parentheses to make sure that it groups them in the denominator of the fraction. So you want to make sure you're careful if you're using a scientific calculator and you end up with a square root in the denominator. Other than that, you should be able, especially if you're using Desmos, it really nicely groups things and shows you how it's grouped. So other than that, it shouldn't be too bad. This one was 60. All right. So from there, it's pretty much just the same kind of stuff that we did on our examples. So that is your assignment for today, just this one IXL section. If you would like to go over some with me or you have questions about registration for classes, please stick around. Otherwise, you guys are free to go and enjoy your weekend.